Hello, welcome to the demo for Altos, the complete sky system for Unity. This demonstration will include a summary of the different features that we have in Altos. So I'm going to talk about initial setup, the time of day manager and the day-night system, our moon and star system, and our volumetric clouds, 2D clouds, and Skybox cloud systems as well. We will start by going through the initial setup, supposing you had just purchased and downloaded Altos into your game, and you want to use it for your game. So what you're going to want to do is you just imported it into your project. You have it here. You're going to want to go ahead and right click in your scene hierarchy and then go down to Skybox director. You're going to click on that, and let's suppose you probably already have a directional light in use in your scene. You're going to want to deactivate that existing directional light in your scene, since we have in Altos already a sun lamp and a moon lamp that are in use. Now you're going to want to go over to your lighting settings and make sure that you have your sun lamp set up and your Skybox material in use here. Looks good. And then we're going to go ahead and go down to your forward renderer and make sure that we add the necessary renderer features in order to make sure that this is working correctly. So the key things you're going to want to add is your stars render feature, your Skybox clouds feature, and your depth fog render feature. You're not done just yet. You need to make sure that your stars and moon lamp are set on their own layers. So I've already created these, but you're going to want to bring your stars over to your stars layer, your moon over to your moon layer. Your project may not have these, you may need to add them. Going back to your forward renderer, you're going to want to make sure that your opaque and transparent layer masks exclude the moon and stars. The renderer features will take care of rendering those aspects of this asset. And also in your render pipeline asset, you're going to want to make sure that you turn on your depth texture and your opaque texture as well. I like to bring this down to none. And that's it. You're completely set up with Altos, and now you can get to configuring it as you see fit for your project. But as you can see, the default looks and interacts amazingly with this scene. It looks beautiful, and if you wanted to stop here, you totally could. Next thing you're going to want to set up is your Skybox definition. So here we have our Skybox definition. This controls the major settings for your Skybox. So you're going to have your periods of day, your time settings, your sun settings, your Skybox cloud settings, and your fog settings. We're going to start up here at the top for your periods of day. These are absolutely critical to making your scene look good, and they are 100% customizable. So you can see I'm just dragging around this color here. You can have literally any color you want as the sky color, which is amazing and very freeing. And you can also control the start and end times for these different periods of day. So as you can see, I scrub through here and we can see we're moving through these different times of day. But you can also add in additional times of day. For example, if you want to add in a super dark nighttime after night started, then we can go in here, bring this down, make this really, really dark. And this one can go really dark too. Let's just suppose that everything is completely black, right? So a lot of control there, a lot of power there. The nighttime, I do recommend starting it at or after 18 here. That corresponds to 6 o'clock, which is when the sun goes below the horizon. You don't want everything going completely black before the sun goes below the horizon. And usually after the sun goes below the horizon, you're going to see a little bit of sort of fading out there as well. So something like that looks good to me. And then you have your real seconds to game hours. This is extremely important and controls the rate at which your day-night simulation will progress in your game. If you want to make a game that has, day day cycle, night cycle, different things happening at daytime, different things happening at nighttime. This is the asset for you. You're going to see here that the sky automatically progresses through the day, through the night. You have the stars in the background, the clouds automatically adapting to the different times of day. And you can go ahead and slow that down as well. If you want to bring that all the way down, you can see the current game time moving more slowly here. Let's go way down. Now it's stopped, right? So that's one thing that's really important, is you can make that completely stop, lock it in. That's perfect for static scenes where you might not want a day-night cycle, but it is available if you want it. And the next thing that you're going to see is this sun base rotation. This controls the angle of the sun in the sky. Let's go ahead and pause the rotation here. Then you can bring the sun base rotation around and you'll see how it moves the sun through the sky. It controls the angle of the sun in the sky. So it's really important to get the right mood for your scene. And make sure that you set that up correctly for your scene so that your scene is looking as best as it can. And then your intensity here. Some scenes you're going to want to bring that way up. Some scenes you're going to want to bring it way down. I think for this one, something quite high does look really nice. Okay. And then you can also control the size of the sun in the sky as well as the color of the sun in the sky. So let's say you wanted to have a completely white sky with a pink sun in it. So let's go white, white, and the sun color. Where is pink? Right there. Pink sun. Boom. Okay. So let's go ahead and bring that back a little bit. Maybe the sun's a little bit more white over here. And perfect. So let me go ahead and show you the cloud settings as well. But we'll actually cover the cloud settings as part of the cloud section of this. And before we do that, we'll talk about fog. So here the fog we're using is linear fog, perfect for mobile devices, very lightweight. Looks great on high-end devices too. Your fog color blend is really important. Lets you blend between a given base fog color and the horizon color of your scene, which lets you change the color of the fog throughout the time of day. So you can see there it just automatically went from more of a blue color during the day to more of a orange color, and then as we got into the nighttime, it changed again. You can adjust the extent to which the settings affect that fog. You can also change the base color of that fog as well. So the clouds are, in my opinion, the coolest part of this asset, and it's something that I've been working on for almost a year now. So it's really cool to see how amazing these clouds really do look. We're going to start with the volumetric clouds, move on to the high altitude clouds, and then end up at the 2D Skybox clouds. So let's go ahead and bring these all the way down, all the way down, all the way down. And then we will start from scratch. So the first thing we're going to look at is the low altitude clouds. And I will use this weather map. Perfect. So the weather map here defines basically like where clouds are, and then into that weather map we etch out, we sketch, we shape the cloud shapes into the scene. Let's bring this up as well to have some clouds going on in the distance too, and you can adjust the distance at which that distant coverage starts. So let's see. So the coolest part about these clouds is really the ability to bring this step count all the way down. This is the main performance control. You can see when we bring that down, the clouds barely are rendering there, but as we bring it up, we start rendering the clouds into the scene, and even as low as 8-10 samples through this cloud shape, we're getting really detailed, really high quality clouds. And that's thanks to the powerful temporal anti-aliasing that I've implemented into this scene, into this asset. So you can see with temporal anti-aliasing off, instantly becomes very jittery, very unsmooth. And then once you pop that temporal anti-aliasing on, it looks so smooth, so perfect, right? Extremely realistic. And we can bring that TAA blend factor up or down to affect the extent to which we use the results of the temporal anti-aliasing texture. The other really important performance setting that we have here is the render scale. So render scale controls the size of the texture that we're rendering the clouds onto. In this example, we're at half scale, so we're rendering at half of the full HD size of the original source image. You can bump that up to full. Looks pretty similar in my opinion. Half gets you 4 times the performance, so I would recommend that. You can also bring it down to quarter, or you can set a custom value, which you can use to tailor the performance to the exact platform that you're aiming at. So if you bring that render scale all the way down to 0.1, you're gonna have really low cost, especially with a low step count here. And you can see that this just looks, I mean, it looks like clouds. Maybe they're a bit blurry, but they're definitely clouds. And you can have these in your game. So let's bring that back up to half here for the demonstration. And let's bring the step count. Honestly, I can barely see any difference once you start getting above 10, which is highly performant. So we'll just keep it here at 18. The depth call options, this is going to be really important for you when you're setting up your clouds based on how you need the clouds to work in your scene. Having the clouds render as Skybox is great if you're not having your players actually go into the cloud shape itself. But you can go up into the clouds in this scene. These are fully 3D, fully volumetric clouds that the player can go inside of. When you are in the clouds, you're going to want to bring the step count up. It's very important. The clouds do not look that great if you're inside of them at a low step count. But look here, you can see an issue already starting to pop up, which is that the clouds are rendering behind the opaque geometry. The way you fix that is just going to your depth call options, changing render as Skybox to render local, and immediately you've got these clouds popping in front of the geometry that is behind them. Note that at this particular moment, the cloud rendering and the depth fog rendering are not compatible with one another. So if you do want to use the render local setting for the clouds, you're going to want to make sure that your depth fog is turned off so that you can use the cloud rendering correctly. That is something that I'm looking into and will be included in a future version of the app. But you can see here, the clouds are rendering in front of the opaque geometry in the scene with this setting turned on. Let's go scrub through the time setting just a little bit, see how that looks. Wow. I mean, those are clouds. So let's go ahead and pop back down to the main camera here. And take a look through there. Perfect. One thing that you can see is when you do have render local turned on, there is a bit of artifacting around the edges of the opaque geometry in the scene, unless you are at full scale render scale. So if you are using render local, keep that in mind. That is one of the limitations. So generally, I recommend render as Skybox unless you have particular applications for having the players fly in and out of the clouds. Next thing we're going to look at is the lighting and atmosphere components. So the lighting allows you to really affect the color of the clouds using the sun color, using the ambient exposure, using the Henny-Greenstein scale strength, using the forward eccentricity and backward eccentricity as well. And then when we get to that atmosphere, this lets you really tailor the actual radius of the planet. So we're really constructing what this asset does is it really constructs a sample atmosphere. And then as you can see, as we increase the radius of this imaginary planet, You can see the atmosphere wrapping around that imaginary planet. So I've included some example planets or celestial bodies that you can use for your project: Earth, Mars, Venus, Luna, Titan, and Enceladus. These are all examples, and you can use them in your project, or you can set your own custom values. And you have the cloud layer altitude, which controls the height at which the cloud layer starts; cloud layer thickness, which affects the thickness of the cloud layer itself; the cloud fade distance. As you bring that in, the clouds fade out sooner. As you bring it out, they fade out later. This does affect performance, so bringing that way down will make your application more performant. And you can see the fog power coming into effect here. So the fog power will affect the extent to which the clouds are colored by fog. Something between 0.5 and 3 looks really good. It does depend on your cloud fade distance though, so keep that in mind if you are changing that around a lot. And now we will look at the low altitude and high altitude and 2D Skybox cloud configurations. Okay, so these are the low altitude clouds. These are the bread and butter, the volumetric, the beautiful clouds that we have in this asset. The main things that you're going to want to look at are these major sections: modeling, lighting, weather, base texture, detail texture 1 and 2, and curl texture. For modeling, we have the extinction coefficient. This is extremely important. It controls the density of the cloud. Something around 100 is physically realistic for these types of clouds, but you can bring it down, it looks beautiful. Bring it up, it looks very stylized. Keep that in mind. Settings go, you can bring this really high, okay, and it'll look really different. The cloudiness setting controls the extent to which we etch out that core weather map, this one here, with the cloud data, the volumetric cloud shapes. And then we have cloudiness density influence. If we bring this down, as we bring the cloudiness down, the shapes still stay really dense. If we bring this up, the shapes start to fade out as we bring that down. I recommend a value around 0.3, but what looks good to you looks good to you. And the height density influence controls the extent to which the clouds fade out towards the bottom. Clouds are less dense towards the bottom, so keep that in mind. You want to make sure that you use this to fade those clouds out towards the bottom. This distant coverage controls the extent to which the cloudiness factor is set, starting at a particular distance from the camera. So bringing this up will cause the distant clouds to become thicker. Bring this down will cause them to fade out. If this is all the way down, I would recommend taking a look at your cloud fade distance, probably reining that back in as well. Okay, so lighting. This is extremely important. The max lighting distance, you probably won't have to touch this, but doing so can cause errors if you bring it too low. Bringing it too high can not really cause too much of an error since I do clamp it, but values around 2000 look pretty good. Basically, if the sun is almost parallel to the cloud plane, this will decide the total distance at which clouds will get shadows from neighboring clouds. Otherwise, they'll mostly just reach all the way through the atmosphere. And then your multiple scattering. This controls the extent to which we capture lighting data deeper into the clouds. Brings all the way down. Let me turn the ambient exposure down too so you can really see this. You can see the bottom of the clouds is really dark here. Popping that up to 1 octave, you immediately start to get a lot more detail in the bottom of the cloud. 3 octaves, even more detail. 4 octaves, even more. I keep this around 3. I think it looks good enough. And then you can adjust the amplitude gain. So this is the extent to which each of the octaves affects the final result. And then the density gain, which affects sort of like the fuzziness of the results. Bring this up, makes the results a little bit tighter. Bring this down, makes the results a little bit smoother. Something like, I don't know, that. Beautiful. Your weather map texture, you can swap these in and out. I've included a couple of examples here. It instantly changes the sort of look of the cloud structure. You can also alter these yourself. They're just single channel noise textures. that define where the cloud shapes should occur. So you can use that for your art needs based on where you need the sun to be coming from, what shape the clouds need to be in. You can even make smiley faces with them if you'd like. This base texture and detail texture are really where we get into what sort of shape, what sort of texture the clouds have. You can see if we swap this out, boom, instant cloud shape change, same there. Bring this back, you also have your quality settings. So this will increase or decrease the performance cost of this asset. Bring this all the way up is more expensive, it does look better. Also bring your scale down, not really something you want to do since you're getting less bang for your buck. Bring the scale up can look really good. Make sure to set your time scale so that the clouds move through the scene instead of just being completely static. Here's an example with it off for the base texture alone. And then you have the texture channel strength. This is present both in the base texture as well as the detail texture 1 and detail texture 2, which I have off right now. Basically it defines how much each of the different texture channels is affecting the final result. Changing this around can cause you to have different results, which can look really good. Very beautiful. I typically think linear looks fine, and you can also set a custom value yourself if you'd like. Ooh. For me, I don't want to mess with the dials. I have linear. Detail texture 1, you can change out the type of texture you're using. I like Whirly for this application. And then you can control the strength as well, which affects the extent to which this Whirly volumetric 3D texture will etch into the cloud shape that we've created from the 2D weather texture along with our volumetric Perlin Whirly texture up here. And your height remap allows you to control the extent to which the strength of this volumetric texture is being implemented over the height of the atmosphere. So in this particular case, we're going from 0 to 0.2, which means that from the bottom to 1/5 of the way through the atmosphere, we are going from a strength of 0 to a strength of 0.5 here. And then the scale, you can completely adjust the scale here to what looks good to you. Sometimes I bring this way up. Sometimes I set it to 200. Do what looks good to you. And then the curl texture, this is super important. Lets you move the cloud shape around in a way that looks a little bit more fluid, a little bit more realistic. So keep that in mind, and it's something that can really up the level of your scene here. You can use that to also affect the base texture as well, like that. So high altitude clouds, let's turn these guys off. Turn those off. Well, in the distance, you know, that looks good. Keep that on. Okay. Don't need so many steps though, so let's bring that down a little bit. High altitude clouds. This is the first sort of cloud layer that you'll encounter after the volumetric clouds. This is rendered just at the tippy top part of the atmosphere that's being rendered for our volumetric clouds. Again, the extinction coefficient here defines how thick, how dense these clouds are. These do have some lighting influence, so keep that in mind. They will be affected by the position of the sun in the sky, and you can control the strength of the textures that you're using here down below. So those are the high altitude clouds. You can swap in and out different textures. I don't know. I'll just pop in this weather map, for example. Okay. You can use whatever textures you want. In the asset itself, I include some example textures of abstract noise that I made for you to use. Clouds, fire, flower petals, liquid, more flower petals. These different options let you really customize it based on sort of naturally occurring shapes that I think look really cool. Feel free to author your own textures and use them instead. So those are the high altitude clouds, and then we'll take a look at the Skybox clouds. So these are also rendered using two 2D textures. Here I have tiling clouds and tiling liquid swirl. And then you can bring the cloudiness up here. These tile in a different way, move in a different way than the high altitude clouds and the volumetric clouds. So keep that in mind. Bringing all three of these cloud layers into effect at the same time can have a really cool result. You can adjust the speed at which they move, and you can bring the cloudiness down. You can also control the sharpness. Bring the sharpness down makes those edges really harsh. Bring the softness up makes it really gentle. So gentle that you might need to bring this way up just to even see it. You can control the cloud color here. Oh, let's bring this up a little bit so that we can see it. Perfect. Control the color, the opacity, the shading color, the shading threshold. Something like that looks good. The shading sharpness. Get really sharp edges, really soft edges. Shading strength. And then night luminance multiplier. That affects the extent to which the cloud lighting for those skybox clouds is attenuated during the evening hours. And then this alternate UV at zenith, that's very important. You can see here, if we don't have that brought up at all, we're gonna have pulling at the top of the scene. You're gonna wanna bring this out so that the clouds render outside of that area nicely. Basically, we're interpolating between a flat plane at the top and then that sphere map, which you could see when we brought that all the way down. Do what looks good to you. Bring it all the way down can look good. Bring it mostly up can look good. Just be conscious and keep that in mind. So those are the Skybox clouds and the volumetric clouds. Next, we will take a look at the stars and moon. Okay, so this is my third time re-recording the moon section. For some reason, I can't seem to record it properly, so just doesn't want to be seen by the public, I guess. So this is the moon. If you go to your moon lamp, it's rendered by a visual effect. And it has a light component attached to it so that it does cast light, and you can control the temperature of that lighting as well as the intensity. I think a lower value looks quite good, so maybe something like 0.3 here. Note that URP currently does not support multiple directional light shadows, so this has a shadow type set to no shadows. It's rendered by this visual effect. You can actually swap out the mesh that is used for rendering the moon. If you open up that visual effect, we'll swap it out for something random that I have. What looks good to us? A paint bucket, perhaps? We'll just use this for now. Save that. And suddenly you have this object acting as your moon, so to speak. So this gives you a lot of control over like how you actually want your sky to look. You can see that it is rotating still. You can see that it's still rotating. You can cause it to rotate more or less quickly, as well as controlling the lighting on this object. We're going to swap this back to the default sphere that is included. Okay, but that just shows some of the power that's available here. I'll talk a little bit about the different rotation speed parameters. You can control the, actually, so for the moon, there's a couple different things that happen as the moon sort of exists in the sky above us. So the first thing is that the Earth itself rotates, causing the moon to have an apparent movement through the sky, through the night and through the day. So that's the Earth rotation speed parameter that controls the rate at which the Earth is simulated to be rotating, causing the moon to appear to rotate through the sky. The next is the moon rotation speed. The moon also rotates itself. And so as you increase or decrease this, you can see the moon rotating more or less quickly. So as the moon progresses, you'll see those phases change, and we simulate that fully here with the phase offset and phase axis rotation settings. I'll turn the phase pass-through speed off. This controls the rate at which the moon moves through the different phases. The first thing that you can change is the phase offset. You can see you can tweak this setting here to cause the moon to move through the different stages of its phase. And then the phase axis rotation allows you to change the axis of the sort of apparent position of the sun relative to the moon. So these two things together are extremely powerful, and you can also set the phase pass-through speed so that the moon moves through its phases very quickly or very slowly. This moon is rendered using albedo and normal maps provided by NASA. So this is physically based on the moon itself. And I intend to provide additional improved shading based on the moon surface shading parameters as well to get even more realistic moonlighting conditions in the future. You can control the normal strength as well, which allows you to increase the strength of the shading there. I think a value around 0.2 looks good. And then the atmosphere blend allows you to blend the moon out of the atmosphere or into the atmosphere. And when it is blending into the atmosphere, it continues to occlude the stars that would be rendered behind it, which is really powerful because it allows you to imply the presence of a moon without actually having, without actually showing the moon brightly in the sky. And even when the moon is dark, you can still see the shape of the moon with the negative space that is created. Okay, so let's hit play. We'll see the moon go through some of its rotation through the sky. And let's bring this back to maybe something a little bit more blue. And then we'll go ahead and hit play and watch the moon go through the sky. I think a slightly stronger atmosphere blend will be good. And you can see here those stars that are still visible during the daytime due to the star settings that we'll cover. You can also adjust all of these settings in real time. In order to customize the look of your scene. Okay, so that's the moon, something that I'm really proud of. I think it looks amazing, really cool, and something that I put a lot of work into to make sure that it accurately represents the way that the moon would look in real life as it passes through the sky and through its phases. So thanks for watching this section, and then we'll move on to the next. All right, so let's look at the stars. So stars are a really cool aspect of this asset. So you can bring the number of stars up and down. You can have millions, billions of stars, as many as you want, right? Right here we have around, let's say 10,000, which is pretty similar to the amount that you would be able to visually see, although they would be a bit darker, most of them. So we're gonna bring these colors down. So these can basically, like, we spawn a bunch of these stars, and their colors are picked from this range, which is defined by this gradient here. So use that gradient to define the range of colors that your stars can be. Use the size to define the base size of the star, and then the size range to define the maximum size of the star above the size. So setting it to a 0 will cause all of your stars to be the same size, and then setting this size range higher will cause them to gradually get bigger and bigger. One really cool thing that you can do with this is change out the different textures for stars. So I included some examples here. My favorite is the hard particle, but first I'll show you this cross. And then if you bring this texture angle up, you can see it's really interesting effect that you can have in your scene. Not my favorite effect, but very interesting. This one is perhaps my favorite. It feels like I'm in a magical wonderland. It is so cool. And you're gonna bring that down a little bit. Maybe bring that one right around there, and looks good. So then you can also adjust the peak brightness. These stars automatically oscillate their brightness at the rate that is defined here. So you can have them oscillate their brightness very quickly or very slowly. And you can also adjust the brightness of the stars during daytime. So let's go ahead and scrub over to a daytime scene so you can see those stars still present even during the day, which can be really beautiful, really cool. And you can bring that down just so that it's a very faint effect as well. But just know that when you're in the editor, you won't see the effect of that unless you go back and forth between the time of day setting there. So bringing that all the way down, for example, you'll have to go back here and then see the results of that change. That's one of the many performance optimizations that we have in this system to make it really super fast at runtime for you. And the stars also rotate, making that is a bit too high, but let's see. Bring that brightness up, bring this over. There you go. So you can see the stars rotating here. That's very fast. You probably don't want that. Something slow looks nice. Something very slow also looks nice. Very tasteful. And then you can also control the distance from which to the horizon at which the stars sort of fade in and out. And yeah, that's the stars. I think they're really cool, really beautiful. You can also fade them or rotate them the other way, sorry. And yeah, I think that's all I wanted to cover for today. So those are all the features of Altos. We have the Skybox director, the sun lamp, the moon lamp, the stars, the volumetric clouds, the high altitude clouds, the Skybox clouds. Altogether, these make Altos an extremely powerful sky system for your game in Unity. Please do check it out on the asset store if you are not already there. And if you have any questions, feedback, comments, feature additions or changes or anything like that that you would like to see for this application, let me know. I'm always here. I'm on Twitter at Oka Software, and thanks for watching.